Let's practice some of this math. So for example 1, if a bear runs about 8.3 meters per second north, how far would it travel in 180 minutes? The first thing is always to write down what you know, what's given in the problem. If you look at the units, you can see meters per second is a velocity or speed. So we know our velocity is 8.3 meters per second north. Because it's a velocity, it should have direction of some sort. And how far would it travel in 180 minutes? You should know that minutes is how we measure time. And this question is asking you for how far would it travel. So that's going to be distance. The next thing you should do is check your units. This has meters and seconds, and this has minutes. You're going to have to convert this into seconds. You should probably know that 1 minute has 60 seconds. So if we multiply this 180 minutes times 60 seconds, we'll get 10,800 seconds. And it's important to do this so that your units cancel out correctly and you'll get meters for your distance. Now let's talk about our equation. You know the velocity equals distance over time. And we need to rearrange to solve for distance. Some of you can do this algebra really easily, at least for this one. Some of you struggle with it, depending on where you are in your math skills. Some of you can do this one, but have a really hard time solving for time. So I'm going to show you a quick trick over here that I call the magic triangle. And you can do this with any 3-variable equation. Draw a triangle and make it have 3 spots. And we're going to say, distance is over time. So we're going to have distance over time, and velocity goes here. And you can see if you don't look at velocity, you get velocity equals d over t. If you want to know time, time equals d over v. And distance equals v times t because it's next to it. So this is a quick way to help you rearrange an equation to solve for any variable. So if we look at our magic triangle, d equals v times t. Be careful about capitalization here. Lowercase v is velocity, capital V is volume. It does make a difference, so be consistent. So our d equals our velocity. We don't have to include the north if we don't want to in our math part here. Meters per second. And you can see that the seconds cancel out, giving us meters, which is good since it's a distance. And we get 89,640 meters. Do me a favor and circle your answer or highlight it to make it easier to grade. When I ask you to show your work, I have to see this part right here. This is what I have to see. If you show me what you know, that also helps me track down an error if you're making a mistake, but there is no negotiating on I have to see this step right here. Let's look at example 2. A sloth moves forward 0.744 meters per second. How long will it take this sloth to move 4 meters? So we can again look at our units, and that's a velocity. And 4.0 meters is the distance. And it's asking how long. So we're solving for time. Let's check our units. This is meters and seconds, and this is meters, so they're match and they're going to cancel out correctly. Let's look back up here at our magic triangle. If we're solving for t, we get d over v. So t equals d over v. And we can plug our values into this equation. And I'm going to write the units this way for a second so we can talk about those. If we do the math here, we get 5.38. Please don't give me every digit in your calculator. Give me a reasonable amount. About 2 decimals and a number like this is fine. And if we look at our units, meters cancels out. And remember, if you divide by a fraction, it's the same thing as multiplying by its reciprocal. So really, we're multiplying by this. So the meters cancel out and give us seconds, which is a correct unit for time. Make sure that your units at the end are a realistic unit for that measure. Let's do a few more examples to make sure that you guys feel comfortable with this. Okay, example 3. A river flows at a speed of 0.5 meters per second downstream. How long will it take a boy sitting on a raft to go 95 meters down the river? And I don't know if you've noticed, but all of our velocities have had a direction of some sort. In this case, it's downstream. So we're writing down the information we are given, and we want to know how long how long it takes for him to go this distance. So there are always clues in the question and in the units to what measurement that is. And it asks you about how long. So we could sketch another magic triangle over here. And if we're solving for time, we have d over v. And I always like to write the equation first. It helps me remember them and helps me remember how I rearrange them. Eventually you'll start to see them enough that you remember what t equals each time. So it would take the boy 190 seconds. Let's do one more. A pizza delivery boy pedals his bike 4 meters per second. That's a velocity. How far, so we know we're solving for distance, will he travel in 15 minutes? And hopefully you've already noticed the issue with the units. This is in meters and seconds. This is in minutes. So we're going to do times 60. And 15 minutes is 900 seconds. And now our seconds will cancel out to give us meters. We want to solve for distance. Distance equals v times t. So 4 meters per second times 900 seconds. The seconds cancel out. And gives us 3,600 meters. This half of the course has this kind of math in almost every single chapter. So you need to get comfortable with it. If you struggle with the algebra, please use this magic triangle. If you don't really understand the magic triangle, send me a message so I can help you. It will be a good tool for you. Even if you are traditionally good at the algebra, you might sketch it and check your rearranged equations with it because everybody makes mistakes from time to time. Please let me know if you have any questions. Try a few of the practice problems below so that you can see if you're doing these correctly. If not, send me a message and I can help you out.